Hey guys, it's Mr. Hill here and my lovely assistant Ryan. Here you go. Where is she? There she is. This is my third grade daughter. She's going to help me out with some demonstrations I'm going to do here shortly. And she's a big weather bug, so she gets excited about this kind of thing. We're coming at you from my garage of science and mystical wonders. All kinds of fun things happen out here, and it's kind of my happy place. That's where I like to spend a lot of my time. Anyway, we are going to talk real quick about air pressure because it's kind of important that, well, not kind of, it's actually super important that you understand what is going on with air pressure so that you can better understand what it looks like when, or how it works, I guess, and relates to weather as far as the water cycle and predicting weather and what global and local weather patterns. So, first of all, the atmosphere is quite literally a blanket of gases that surrounds the earth. If you see the arrows in the picture here, they're pointing toward the center of the earth, which we know is a solid nickel and iron core surrounded by a molten liquid nickel and iron core that is super dense. They're heavy metals, right? So they're super dense. That means the gravity of the earth is always pulling toward the center. That's why you're not upside down when you're in Antarctica. Because up is always over your head, down is always relative to below your feet. The gravity is what's holding that blanket of gases, the atmosphere, to the earth. Now, as that is pushing down against you, it's important to realize that it's putting pressure on you. Now, if you look over here, think about a 1 square inch. If you've got a ruler around, look at how big 1 inch is. It's not very big. It's a pretty small size. But if you think about a square that's that size, the average air pressure is about 15 psi at sea level. That means roughly we have anywhere between about 14 and a half and 15 and a half pounds per square inch. That means every one of those little inches has 15 pounds of air pushing down upon it. That's a lot, right? It is. You think about how many square inches are on your body. Whoa, that's a whole lot of pounds. So why don't we feel that? Well, it's because our body is acclimated to it. What's funny though is, last week we learned about the barometer and the history of the barometer. And what Summit didn't really mention is our body kind of has a built-in barometer too, and that's our ears. If you've ever gone up a high hill, big tall hill, or even into the mountains, you'll notice your ears will pop. And sometimes you'll notice when you go down into a lower valley, they'll do the same. Another great example I think we can all relate to is when you swim down deep into the pool, and you'll notice that pressure on your ears. That's also an indicator of pressure, and that's our body's own built-in barometer. So I'm going to move back here, and I'm going to have Ryan take my seat, and we're going to do a couple of demonstrations here. All right. So bear with me while I move my, my laptop so that I can get us into position. Let's see if we can see Ryan. Can we see Ryan well? Everyone say hi to Ryan. Okay, there she is. Okay. So first thing I have here is I have a glass of water. Can you guys see that? I'm going to stand back behind her so it's a little more clear. I have a glass of water here. Now look at the space in the glass above the water and below. You pointed that for us, Ryan? There you go. Yeah, there's a pretty big space there, but watch what happens when I turn this cup upside down. Look at that. That space above the water got much bigger. Now, what's happening is the pressure inside the glass is less than the pressure outside of the glass. That means the air pressure is actually holding the plate up against there. Great job, Ryan. Great job. Now I'm going to come over here and I'm going to stop sharing my screen here. Hopefully that